Okay, so in this particular unit, we're going to look at inter and intramolecular forces. So the forces between particles versus the forces that hold particles together. We're going to look at gases, and we're going to look at pressure and temperature and a lot of different things. In terms of the roller coaster ride that we're riding on, we've been climbing this roller coaster to the top. In my opinion, this unit puts us at the top of the roller coaster. All right, so we're almost there, guys. You guys have hung in with me. You've been working hard, and I appreciate that effort. So a couple of different types of units that we can use in terms of measuring pressure. And now these are standard pressures. Okay, so we have atmospheres, 1 ATM for atmosphere. And this is your changing units of pressure and temperature worksheet. We have 760 millimeters of mercury. We have 29.9 inches of mercury. We have 101.325 kilopascals. We have 101.325 pascals. And now this makes sense because kilo, we know that there is 1 kilo equals 1,000 base units. So in this case, Pascal is the base unit. We have 14.7 psi. And we have 760 torr. So all of these are different units of measurement for pressure. And the most common ones that we're going to use are going to be the atmospheres, millimeters of mercury, kilopascals, and torr. But you will see these other ones as well, especially inches of mercury here in the United States, okay, because we don't use the metric system. We use inches and feet. Okay, so these are standard pressures. So these are constant units, all right? So if we wanted to take 557 millimeters of mercury, and I'm being asked to put that into torr. So we're going to do dimensional analysis like we've already learned how to do, where if millimeters of mercury is on top, it is going to go on bottom. And now I can go direct between any of these units because they are all standard units. Okay, so I can go direct from millimeters of mercury to the torr. And I know that for every 760 millimeters of mercury, it is 760 torr. So that is 557, torr. Okay, because millimeters cancel millimeters, leaving us with torr. So on the next one, if we have 557 torr, our worksheets ask us to go to atmospheres. So 557 torr, if torr is on top, it goes on bottom. I can go direct to atmospheres, where 1 atmosphere is 760 torr. And so that is going to give me 0.732 atmospheres. And again, we're still sticking with our rule of 3 here. Okay, so if I have 0.732 atmospheres, my final one in problem number 1 asked me to go to kilopascals. So if atmospheres is on top, it goes on bottom. I can go directly to kilopascals, where 1 atmosphere is 101.325 kilopascals. And so this is going to be 74.3 kilopascals when we plug it into our calculator. On this same worksheet, we also learn how to go from degrees Celsius into what we call Kelvin. All right, so degrees Celsius plus 273 is K, and K stands for Kelvin. Now, Kelvin is going to be how we measure temperature when we do gases. All right, and Kelvin has no number below 0. Okay, so there's no temperature that will ever go below 0. And the reason we measure in Kelvin is because if we were to adjust our graph, we would see by doing Kelvin, it gives us a linear relationship, and it makes our math a lot nicer and a lot easier. So if you're given degrees Celsius to convert into Kelvin, you will simply add 273. If you're given Kelvin and you're asked to find degrees Celsius, you will simply subtract 273. So looking at number 8, if you have 59 Kelvin, how many degrees Celsius is that? So to go Kelvin to degrees Celsius, we are simply going to subtract out 273. And so when you plug this into your calculator, you get negative 214 degrees Celsius. And number 13 gives you 23 degrees Celsius, and it asks you to go into Kelvin. So we're going to simply add 273 here. So when you plug this into your calculator, you may be actually able to do it in your head. You get 296 Kelvin. So gases are going to be measured in one of these units above that we talked about: atmospheres, millimeters of mercury, inches of mercury, kilopascals, pascals, psi, or torr, and that's pounds per square inch. And our temperature for our gases, we're always going to use Kelvin, so you may have to do some conversions.